Welcome back. We continue with examples from problem 0.5. So let's look at number 37. 37 says b cubed. We are still factoring expressions completely. B cubed plus 64. So clearly this is the sum of a cube and this other number that can be written as the cube of some number. All right. So the first thing is to then inquire what 64 is as a cube. So 64 is actually 4 cubed. Okay, it's easy to get this from your calculator by just taking the cube root of 64, right? Cube root of 64 is 4, so 4 cubed is 64. Okay, so once we get this, then it's then clearly a sum of cubes. So we can apply our sum of cubes formula. Recall what the formula is. The formula says x cubed plus y cubed is going to be equal to x plus y times x squared minus xy plus y squared. That is the sum of cubes formula, basically, all right? So using that, we can then apply that to this. So it says that the first thing, add up the two numbers involved, which in this case will be b plus 4. And the next thing, first number squared, so b squared minus the product of the two numbers, 4b plus the square of the next number, 4 squared, which is 16, okay? And that's then the factorization of that particular sum of squares, basically. Okay, let's look at a few more examples. Look at number 25. Okay, I'm just taking them at random. 25 says factor completely u to the power 13 over 5 v minus 4 u to the power 3 over 5 v cubed. Okay, and we want to factor this. So clearly this also doesn't look like a quadratic or a difference of squares or a sum of cubes or anything like that, all right? But looking at this, we have greatest common factors. We have common factors here that we can factor out and see whether what we get in return looks familiar. So let's look at the factors. So u to the power 3 over 5 is common to these two terms, and v is also common to both terms. So if I factor out my u to the 3 over 5 v, right? Now from this term, what am I left with? How much u am I left with? So ask myself, what can I add to 3 over 5 to make 13 over 5? Right? So clearly it's going to be 10 over 5. So that 3 plus 10 will then be 13 or over 5. Okay? So I'm left with 10 u to the 10 over 5 here. And no v. V is already outside. Minus 4. This 4. U to the 3 over 5 is already outside. V is outside, so I'm left with v squared, basically, all right? And 10 over 5, we know is equal to 2. So the whole thing becomes u to the 3 over 5, v times u squared minus 4v squared, right? Now, clearly, the expression in the bracket is a difference of squares, okay? Because we can write it as u to the 3 over 5v u squared minus 2v all squared. So it's a difference of squares. So applying our difference of squares formula now on the bracket, the quantity in the bracket, we get u to the 3 over 5v times u plus 2v times u minus 2v by the difference of squares formula. And that's then the complete factorization of that expression. Complete factorization of that expression. And let's take more examples. Look at number 35. 35 says we should factor y to the 4 plus 8y cubed plus 16y squared. All of this, not times, actually minus, okay, minus y squared plus 8y plus 16, okay? So the first thing we do is to open up our brackets by distributing the negatives minus sign to each of the terms in this bracket, right? So it becomes a y to the 4 plus 8y cubed plus 16y squared minus y squared minus 8y minus 16. Then next we look if we have like terms that we can add and subtract, okay? So we have y squares here, which are like terms, and those are the only like terms. So I then have y to the 4 plus 8y cubed, 16y squared minus y squared is positive 15y squared minus 8y minus 16. Okay, and that's that basically, all right? We can't factor this any further. That's it, okay. Now let's look at that one. Was quite straightforward. Let's look at more examples. Number 40. So 40 says 27 plus 8x cubed, right? Now looking at this already, I can identify it as a sum of cubes type, because I've got the x cubed there. I've got 8, which I can write as 2 cubed. I also have 27, which I can write as 3 cubed, all right? So it will then look like 3 cubed plus 2x all cubed, which is a sum of cubes, right? Which is a sum of cubes. All right, straight up to my sum of cubes formula. So the formula says that x cubed plus y cubed is going to be equal to x plus y times x squared minus xy plus y squared. That's the sum of cubes formula. So applying that to our expression here, it says add up the 2 first, right? So it's a 3 plus 2x, 3 plus 2x first, times the square of the first number, which is 3 squared, which is 9, minus the product of the two numbers. So the two numbers are 3 and 2x. So 3 times 2x will be 6x plus the square of the second number. The second number is 2x, so its square will be 4x squared. Okay, and that's the complete factoring of our thing there. Okay, let's look at more examples. So this one is a quadratic form. It's not a quadratic per se, but it's a quadratic form. It says t to the 4. This is number 48. 48. T to the power 4 minus 4. Okay. So we know that to the power 4 is not necessarily a quadratic, but we can write it as 1, okay? We can write this as t squared minus 2 squared. So it's a difference of squares, okay? We can basically write it as a difference of squares and then work it out using our difference of squares formula. Okay, so it's not a quadratic form, sorry, it's a form of difference of squares. A form of difference of squares. Okay, so that said, our difference of squares says a squared plus b squared will be, or minus, sorry, minus b squared is a minus b times a plus b, right? So my a in this case is t squared. This is my a, everything in the bracket, and my b is 2b there. Okay, so applying the formula a minus b, it will be t squared minus 2 times t squared plus 2, all right? And again, this can be identified as another difference of squares, all right? We can write it as t squared minus square root of 2 squared, okay, basically, which becomes t minus root 2 times t plus root 2 using the difference of squares formula. Then we have that part. That's the complete factoring of our thing there. Okay, let's take number 43. Number 43 says, given p times 1 plus r plus p times 1 plus r times r. Okay, and we want to factor this. So clearly, p times 1 plus r is common to both terms. So p1 plus r can be outside. From this term, we are left with 1 plus. From this term, we are left with r. Okay, so it becomes a p times 1 plus r squared. That's the complete factoring of that expression. Okay, so that's that. That's that. Take one last example before we go. So if we take one last example, this example says factor x I'm just trying to look for a quadratic example because we haven't had a lot of quadratics. 9z squared plus 30z plus 25. And this is number 24, right? Basically, and we want to factor that. So again, we said find two factors of first and last term, which when you cross multiply and add, you get the middle term, okay? So my two factors of 9z squared will be, I'm suggesting 3z and 3z, and my factors of 25 should be 5 and 5. Okay, let's cross multiply and add and see if we get 30z. So 3z times 5z will be 15z plus 3z times 5z, 15z. 15z plus 15z is 30z. So therefore, our factors will be 3z plus 5 times 3z plus 5, basically, right? By trial and error. By trial and error. Okay, look at number 23. Okay, it's a greatest common factor which will then materialize to a trial and error type. It says 12s cubed plus 10s squared minus 8s. All right. So s is common to all three terms, term 1, term 2, term 3, they all contain s. So this can be equal to, now notice that 2 is also common to all three terms. 2 is a factor of this and this and this as well. So 2s can stay outside. From this term, I'm left with 6s squared. 6s squared, right? So that 6s squared times 2s will give me 12x cubed. From this term, I'm left with 5s, right? So that 5s times 2s will give me my 10s squared. And from this term, if I take out 2s, I'm left with 4. Okay? And that's it. Now, looking at this, what we have here is a quadratic, which we need to try to factorize using trial and error. Factor using trial and error. So if we apply trial and error on this, I'm looking for two factors of this and this, which when I cross multiply and add, I get the middle term. So my factors of 6s squared will be 3s and 2s. And my factors of -4 will be, okay, I'm just looking at this. Factors of -4, I can say -2 and 2. Let's try this. This times this will be 6s. And this times this will be 4. 6 minus 4 doesn't give me 5. All right? So I need to have a second look at it. What if I use 4 and 1? I still don't get it. Okay, what if I, instead of using 3s and 2s, I then use my, now sometimes the quadratic equations that you get here may not be factorizable. All right, but this one should be. Okay, let's say I do my 6s and s. It's my factors. Okay, I need 5 in the middle. And then I do my 6 minus 4 doesn't give me 0.1. 6 minus 4 doesn't give me 5, gives me 2. And maybe 2 and 2. So this becomes 12 minus 2 doesn't still give me 5. Okay. Let's see, 3 and 2. And then